In this segment, we're going to talk about solving multiple step equations, so more than two. So I've taken away our teeter-totter piece because we still have our left side and our right side. So this question says 3 times x minus 5 equals 6, or 3 groups of x minus 5 equals 6. And so this bracket means I have x minus 5, and the 3 means I have 3 sets of those. So with my manipulatives, it would look like this. So there's my x and minus 5, and I have to do that 3 times. So my diagram would look like this. Now the way I've set it up, you can see that since I have 3 rows, my 6 divides into 3 rows too. I can do it a couple of different ways. The normal way that we would do it, I'll do that one first, is to distribute the 3 across. So that means I have 3 sets of x's and 3 sets of negative 5 for a total of 15 here. So my work would look like this. And so there it is, 3x minus 15, or 3x and 15 negatives. Then I could bring my 15 negatives over to the right-hand side. And to do that, I could make up my 0 pairs. It means I have to add 15 to both sides. And there it is there. I've taken my 15 reds and I've added 15 greens to make my 0 pairs so they all kind of cancel away. And whatever I did to one side I have to do to the other, so there they are over here on the right hand side. Mathematically my work would look like this, showing that I've added 15 to both sides, which would leave me with just my 3x, and on this side I'd have a total of 21. So there's my work. Continuing with my drawing now looks like this. So my 3x is equal to 21. I can now see that I can take my line and divide it into 3 separate pieces that are of equal size. 1, 2, 3, 4, 5, 6, 7. So any one x would equal 7. So my work I would show mathematically for that, or symbolically, would be this. Showing that I've divided both sides by 3, or into 3 pieces. This dividing line is the same as this black line that I've written here and here. So any one x in any of these 3 rows shows that any one x is equal to 7. So x is equal to 7. Now there's another way that I could have done this. Instead of distributing it across the first, I could have done my division first, because both sides are divisible by 3, and I show you that next. So going back to my original question, 3 sets of x minus 5s. And I can see that, as I said, the way I've got it written up, I can divide them into 3 separate groups. So I could draw my line here, and every piece would have identical pieces. So the first thing I'm going to do is divide both sides by 3. Now remember, I'm dividing a whole side by 3, and so I have to divide both the x by 3 and the minus 5 by 3. So symbolically, I have to make sure that my division line goes across the entire side. And it would look like this. So it looks like that. I'm showing that I've divided the entire side by 3. Now my 3's are able to cancel, and it leaves me with just x minus 5 is equal to 2. So I'm going to divide into 3 pieces. So I'm going to, on any one of my pieces, I'm going to have an x minus 5 is equal to 2. So I'll show that finished work. And notice I can take away the brackets now, because I don't have groups of them anymore. I just basically have any one of these sets, so I don't have to worry about having a bracket around that anymore. So my diagram would look like this now. And I would then move the 5 reds over to the other side by using my 0 pairs, like that. And whatever I do to one side, I have to do to the other, which makes all of these 0 pairs go away. And I'm left with x is equal to 7. And so my work that I would show mathematically would look like this. So I've shown added my 0 pairs here by adding my positive 5's to both sides, and I'm left with just my x is equal to 7. So there's 2 ways we can do this. We can divide away a whole side first, or we can distribute across the brackets. Now in this question it's set up really nicely, but in the next question it may not work quite so well. So in this question, 3x minus 14 is equal to 2 sets of x minus 2's. If I wanted to get rid of the 2 sets by dividing by 2, I can divide the 14 by 2, but my 3 x's are going to be a problem. I can't get 3 things divided into 2 pieces, and it's going to leave me with nice whole numbers. So we can play around with this question. I've also made sure that I've got the bracket over on the right hand side this time, just to show that it doesn't make any difference. And here's my diagram, 3x and negative 14, 2, 4, 6, 8, 10, 12, 14, and is equal to 2 sets of x minus 2. So there's my x minus 2, and I have 2 sets of those. And you can see that if I wanted to draw my line, it looks like it's really quite promising. I can draw my line through here, and then I get to this point here, and I have a problem. What do I do with these 3? Dividing these 3 into 2 is problematic. So here's an example of one where dividing by the entire side by 2 is going to be a bit of a problem. So I think what we'll do on this one is we'll expand across the bracket, distribute across the bracket, and then move the 1's across instead of doing the division step first. So as far as my picture goes, it doesn't really change at all. 2 sets of x minus 2 means I've got 2 x's plus and a minus 4. So my diagram really doesn't have to change when I do my distribution technique. Now I want to move my x's or my 4's and my numbers across. Which one do I want to move? It doesn't really make that much difference. But I notice if I was to subtract 3 x's from this side and subtract 3 x's from this side, I'd end up getting a negative x on this side. So I think what I'll do is I'll move my x's from the right hand side over to the left hand side first by using 0 pairs. So to get rid of my positive x, I need to add some negative x's, and whatever I do to one side I have to do to the other. So my diagram would look like this, and I've effectively made some 0 pairs, so those pair and that pair and this pair and this pair are going to go away. So what am I left with? I'm left with x, and a minus 14 is equal to minus 4. And I'll show all that work here mathematically right now. And so there's my work. I've distributed my 2 across, and there it is at 2x minus 4. And I've shown that I've added my 2 0 pairs. I added my 2 reds that we had up here, and there it is subtracting them. And so this 0 pair here makes it go away, so they're gone up here now. And 3x minus 2x leaves me with 1x. So now I've got 1x minus my 14 is equal to negative 4. So now I know what 1x is equal to. I want to get rid of these minus 14, so I'm going to add 14 to both sides and see what happens. And so I've added my 14 positives to act as 0 pairs to remove my 14 negatives. And here's my work here. I've got 1x minus 14, so I've added 14 positives. So there's my 0 pair right there, or actually 14 sets of 0 pairs. And whatever I do to one side, I do to the other. So that eliminates these 0 pairs. So that leaves me with 2, 4, 6, 8, 10 on this side. So my 1x here is going to equal to these 10 here. And so mathematically my work would look like this, with x equaling 10. Now we can talk about moving, if we had moved the x's to the other side, if we had brought our 3x over to this other side, over to the right now, that would have led us with a negative x, and it still would have worked, but then we would have had to remove that negative at the end. Both techniques would work fine. This is a good time maybe to talk about how to check our answer too. So now we've got our answer of x equaling 10. What might that mean, and how could we go about checking that? Our question said 3 times x minus 14 is equal to 2 sets of x minus 2. And we've said our answer is 10, so we can go back and take a look at our answer. If we put a 10 where the x is, and over here a 10 where the x is, we can take a look and see what we would get. 3 times 10 would give me 30. So I'm just going to write it here. So we have 30 over here. And subtract 14. Subtract 14 is equal to my right side, which says 2 sets of 10 minus 2. Well, 10 minus 2 is 8. And 2 sets of 10 minus 2 is 16. So that would have to equal 16. If I now do my left side, 30 minus 14 is 16, and that's equal to 16. So I can see that my answer is correct, because I can substitute my answer back into where the x was, up here and here, and I get the correct answer. The other thing I want to note is, and I can substitute my x equaling 10 to any of the steps along the way. I could take my 10 and stick it in to this stage of my question. 3 times 10 is 30 minus 14 is equal to 2 times 10, which is 20 minus 4. 20 minus 4 is 16, and I'm back to my 30 minus 14 equals 6. I could stick it into this section here. 10 minus 14 is equal to negative 4. So any place along my work, I should be able to take my answer of x equaling 10 and stick it anywhere in these steps to check to see if I'm doing it correctly. So this final question, we're going to have brackets and variables on both sides and see if that makes any difference to what we've been doing up to now, and it shouldn't. So we've got 3 sets of x plus 5s, and we've got 4 sets of 1 minus 2x's. We can see from our past experience that 3 sets and 4 sets aren't going to divide nicely, so I don't think I'll do the division first technique. And so let's just draw out the question here to see. So there's my x plus 5, and I need 3 of those, so I'm going to duplicate those to get that. And now on the other side I have 1 minus 2x, which looks like this. I have a 1 and 2 negative x's, or negative 2x's, and I need 4 of those because my bracket says I need 4 of those, so I'll duplicate those. So my question looks like this, and we could see it would be really nice if we had 3 x's down here. We could just divide our lines 1, 2, 3, and we'd be great, but we have this one hanging over here, so we can't do that division of both sides by the same thing. So we're going to have to work it the other way, working with the distributive factor first to get rid of my brackets, and then work with our ones. So showing here, I have 3 sets of x plus 5. My diagram doesn't really change, but mathematically I have to show the distribution of that 3 across the bracket. So I'm going to have 3 x's and 15, and now I'm going to have 4 1's, 4 times 1, and 4 times negative 2x gives me negative 8 x's. So mathematically my work would look like this symbolically. And so there's my work symbolically. My picture stays the same. So at this step I have choices. Do I want to move my 1's over to the other side? Or do I want to move my x's from one side of the x? And which side do I want to move them on? My personal preference is to move the x's before I move my numbers, but it doesn't make any difference. So I'm going to move my x's. So if I move these 3 x's over to the other side by putting a 3 reds, I'm going to have a lot of reds. So I think what I'm going to do is I'm going to move my x's from the right hand side over to the left hand side, so they're all going to change to green. So to get rid of my negative 8 x's, I need to add 8 positive x's to get my 0 pair. So there they are there, and I'm going to do the same thing to the other side. And so I've effectively 0 paired those all the way. And so what I've got now is 1, 2, 3, and 8 is 11 of these x's, plus 15 is equal to 4. So I'll show the work for that. And there's my 0 pair. I've added the 8x to both sides. That effectively has gone it away, made it go away. There's my zeros, left with 11x plus 15 is equal to 4. So I've added my 15 reds, so I can get rid of that, and whatever I do to one side I have to do to the other. So my diagram now looks like this, and I have 11 x's is equal to negative 11. And here in my work I've added my negative 15, my 15 reds to both sides, and I get 11 x's is equal to a negative 11. I don't want to know what 11 x's are, I want to know what 1 x is. So I line them all up. And now I've lined them all up. 11 x's is equal to negative 11, and any 1x you can draw a line indicating, if I divide them into 11 separate pieces, every 1x is equal to negative 1. So mathematically, showing I've divided into 11 pieces, divide by 11, so I show my dividing by 11, and x equals negative 1. Any 1x is equal to negative 1. So we can use complicated questions and use the blocks to solve complicated questions as long as we show our steps, and we can show how showing our work that we've done up until now can work on as complicated a question as we want. The steps haven't changed no matter how complicated the questions become. And we've also seen that there's multiple ways of doing it, and as long as you show your work, all ways will work just fine.